Now let's solve some more nonlinear inequalities. Let's solve some inequalities involving a quotient. If this were an equation, this were an equal sign instead of an inequality, you would solve this equation like this. Multiply both sides by 1 minus x. It would cancel out your denominator, and then you could solve 1 plus x equals 1 times 1 minus x. No problem. And it might be tempting to simply multiply both sides of the inequality, because this is not an equation, it's an inequality, by 1 minus x, as you would if this were an equation. But this doesn't work, because we don't know whether 1 minus x is positive or negative. It depends what x is. So we can't tell whether the inequality needs to be reversed. With an equation, there's nothing to reverse. With an inequality, if we multiply or divide by a negative number, we need to reverse the direction of the inequality. So we're going to have to solve this a different way. What we're going to do is get everything on one side and set it equal to 0. Then we can determine whether or not, once it's simplified, we can determine whether our factors are positive or negative, and whether the whole quotient is positive or negative, and looking for our answers. All right, so we have 1 plus x divided by 1 minus x is greater than or equal to 1. We want to move the 1 to the other side, so in other words, we're going to subtract 1 from both sides. So now we have 1 plus x divided by 1 minus x minus 1 is greater than or equal to 0. We need to combine the terms into one fraction. All right, so we need a common denominator. Well, there's only one denominator here, so the least common denominator is 1 minus x. All right, so now we're going to have to change 1 so it has a denominator of 1 minus x. Well, anytime you divide something by itself, right, you get 1. Right? So if I have 1 minus x divided by 1 minus x, that's just 1. So we're going to replace the 1 with 1 minus x divided by 1 minus x. Essentially, we multiplied the numerator and denominator by 1 minus x. Since this is still equal to 1, we haven't changed anything about the inequality except for the way it looks. Right? But this side still means the exact same thing as the step above. We just replace the 1 with 1 minus x over 1 minus x. Just another form of 1. Now let's combine the fractions to one fraction. Since we have a like denominator, all we have to do is add the numerators and keep the denominator. So we have 1 plus x. Now be careful. You're not subtracting 1. You're subtracting 1 minus x. So remember, anytime you've got a subtraction sign there, remember, use parentheses and remember to distribute your negative. All right, so we have minus 1. That's negative. But we have minus a negative x. Right? So if we're subtracting something negative, that's the same as adding. You're taking away something bad, that's good. So that's going to be a plus x. All over our common denominator of 1 minus x is greater than or equal to 0. Now let's combine the like terms. All right, so we have two positive x's, so x plus x is 2x. And then we have 1 minus 1. That's 0. So 2x is our numerator. Our denominator is 1 minus x. It's greater than or equal to 0. All right, so when would our fraction be equal to 0? All right, well, a fraction is equal to 0, right, when the numerator is equal to 0. So we have one factor, 2x is equal to 0. Divide both sides by 2, right? 0 divided by 2 is still 0. But we have another factor there. We have 1 minus x, and we need to consider that factor. We need to consider when 1 minus x is 0 as well, right? Because that's going to make our fraction undefined. So we need to consider that one as well. So we have 1 minus x equal to 0. All right, so we're going to subtract 1. Well, we don't even need to subtract 1 from both sides and divide by negative 1. 1 minus what would equal 0? I think if I subtract 1 from 1, I would get 0. So those are our two, not our solutions. Remember, these are our boundaries. Because our solution is an interval. And we need to use our boundaries to divide up the interval of all real numbers, right, into subintervals so we can check each one. All right, so that means we've got three intervals to check. We need to check negative infinity to 0. We need to check 0 to 1. Oops, that's supposed to be a parentheses. And we need to check 1 to infinity. And I put a sign chart on the next page because I knew I was going to run out of room here. And so that we can check each of those value from each of those boundaries in our factors. And then we can determine whether the factor is, and our factors are 2x and 1 minus x, whether they're positive or negative, and whether the quotient is positive or negative. All right, so when we're doing our checking, we're not going to go back to the original. We're going to go back to our nice simplified one. Because if we could just use the original, we would have, right? We need this one, right, where we're just dealing with positive and negative. That's how we're going to solve all of these nonlinear inequalities. All right, so we have our three intervals there, and we're looking at the sign of each of the factors. Right? Oh, and I forgot to write that this was greater than or equal to 0. All right, so now let's check the sign of 2x. Well, if I plug in if I multiply a negative number by 2, it's still going to be negative, right? Except, of course, at the boundary, except, of course, at 0, right? So at 0, that's 0. But anything less than 0 is going to be negative. So this is negative. All right, so how about 1 minus x? All right, so if I plug in something negative, if I'm subtracting something negative, I'm adding something positive. If you're not sure, take any value in the interval. Don't take the endpoints, right? Because sometimes the endpoints are going to be different, right? Then they're not going to satisfy the equation. It all depends on whether they're less than and greater than, or less than and equal to, or greater than or equal to. All right, so, but take anything at all in the interval. Negative 1, right? So 1 minus a negative 1, well, that's 2. If you're not sure, take another one, negative 5. That's in the interval negative infinity to 0. 1 minus a negative 5, that'd be 1 plus 5, that's 6. So you say you get a positive number if you subtract something negative. Let me move this out of the way because we don't really need it. So the sign for this interval is going to be positive. Right? So if you're not sure, just take any value from the interval, just not the endpoints. Well, of course, you couldn't take negative infinity and plug that in, but any number between negative infinity and 0, that's not 0. So if you divide a negative by a positive, you get something negative. Now let's look at the next interval, 0 to 1. Right? Well, there's not a lot of space, not a lot of values in there. Let's do a half. All right? So, well, there's an infinite number of values, but there's no integers. All right? So, but a half is a nice number. 2 times a half, that's 1. That's positive, right? That means everything in the interval is positive. All right? So now, what if we took a half from 1, right? So 1 minus a half. You can just do the same value. Well, that's going to be positive a half. So everything in the interval of 0 to 1 is positive, of course, except at 1. All right, so now if you divide a positive number by a positive number, you get something positive. All right, so 1 to infinity. All right, so if I multiply anything greater than, if I multiply a positive number by 2, I'm just going to get another positive number. What about in the next one? All right, so let's take a number, right? 5, that's a nice number. 1 minus 5, that's negative 4. 2, 1 minus 2, negative 1. So if I'm subtracting something positive from 1, anything greater than 1 is going to be negative. So the sign of 1 minus x for values greater than 1 is negative. If I take a positive number and divide by a negative number, I'm going to get something negative. All right, so now which of the intervals, it can be more than one. Matter of fact, if this had said, well, we'll talk about that if this had said less than. But we're looking at greater than. So we're looking at something positive. All right, so we're talking about this interval here. I'll just put a star. We're talking about that interval there. That's where the sign of 2x divided by 1 minus x is greater than 0. The only thing now we have to consider is, do the endpoints count? All right, so can 2x divided by 1 minus x equal 0? Well, yes, it can, right? Because it's greater than or equal to 0. So I'm okay plugging 0 in, right? Because if I plug 0 in, let's just do it over here. I have 2 times 0 over 1 minus x. Is that greater than, oops. Let's plug in at 0 for all the x's now. All right, is that greater than 0? Greater than or equal to 0. Well, that would be 0 divided by 1. And that's 0. So 0 is indeed greater than or equal to 0, right? Because it's the equal part. All right, so we're cool with 0. All right, so our solution will include 0. How about the 1? Can we include that one? All right, let's plug 1 in. 2 times 1 divided by 1 minus 1, is that greater than or equal to 0? Well, I have 2 divided by 0, and I have a real problem with that, because this is not a real number, all right? So we can't plug the 1 in, because now our fraction is undefined. We've got an undefined inequality. So we can get as close as you could conceivably get, and get closer and closer, but we just can't reach 1. So 0 is included, so we're going to use a bracket. 1 is not included, right, because that would be undefined. So we're going to use a parentheses there. This is our solution in interval notation. Let's do it also in set notation. I am fine with whichever form you use, but I want you to be exposed to both interval notation and set notation so that you understand it when you see it. All right, so that thing is supposed to be a brace. I, for the life of me, can't draw the stupid things. All right. So that's good enough. It looks close enough to a brace. All right, so that brace there is saying this is going to be in set notation, that we're talking about a set here. So we're talking about x such that x is equal to is greater than or equal to 0 but less than 1. So we have the greater than or equal to, so notice x is on the greater side, right? It's at the open side, all right? So that is saying x is going to can be greater than or equal to 0, but it's got to be less than 1 because we'll have a problem if it's equal to 1. And this is called set notation. It's not really very difficult. It's just new, all right? So there's this equation all done, or excuse me, this inequality all solved. And we've got our solution in interval notation and set notation, all right? Oh, hey, let's graph it. And let's not forget to graph it. Am I going to get it? Yeah, I'm going to get it a line, but here we go. I'll just draw the arrows in. All right, so, -2, -1, oops. Oh, now, oh well, let's try that again. My 0 ended up in the wrong spot. -2, what the heck? And now, by the way, it's nighttime. I don't know if you can see the time, and the lights just went out. And so now I'm in the dark. If I don't move around enough, they go off. All right, so we are including 0. Actually, I'm going to do it in a bright color. We're including 0, so we're going to have a closed dot there. We are not including 1, so we're going to have an open dot. right? You could also do this, and this would also be acceptable. Just so you know every possible way. All right. If you have any issues with closed and open, like, I don't know, they always look close when you try to draw them, you could also do this. Bracket, parentheses. I'm not very good at that. See, look at, mine just don't, if I type it, it's fine. Let's try to make that look more brackety. So you could also do this. I just don't do that well. So I prefer closed dot and open dot because my brackets and my parentheses look just a little too much alike. But if you're really good with the bracket and the parentheses and you like that better, that's another way. I think you might find the top one a little easier, at least I do. All right, let's do one more problem. Actually, you know what? I'm gonna stop this video and I'm going to do one more problem on the next video so the videos aren't too long. All right, so come join me in the next problem. And it's going to be, I think, a little faster. All right, bye for now.